This is Kate Winters for Physics 1251, our video generating assignment for problem set 9. I'm going to go over the power winch skier problems. So the first thing that I do anytime that I'm approaching a word problem is to write down all of the knowns. In this case, one of the first things we're told is that the mass of the skier is equal to 31.8 kilograms. So I go ahead and write that down first so that I have that to work from. We're also told that the coefficient of friction, of kinetic friction, is 0.18. We're told that the angle that the ramp makes with the horizontal is 20 degrees. And we're also told that the skier moves at a constant velocity of 1.76 meters per second. So there's a couple main things that I think of right off the bat when I hear this. And first of all, the constant velocity tells me that all of the forces on the skier, the net forces in all directions, are equal to 0 because it's a constant velocity, so there's no acceleration. So the first thing that I'm going to go ahead and do is set up a free body diagram and solve those equations since I can set them equal to 0. In this case, the free body diagram includes a force of gravity straight down, a normal force from the ramp that's perpendicular to the surface, the force of the winch or motor or whatever that thing at the top is, and the force of kinetic friction directly opposing the motion of the skier. So that's what the free body diagram looks like, and I'm going to go ahead and add an axis here so that I know that theta is 20 degrees. The first thing I'm going to do is start with the y direction, and I'm going to set my positive x direction to be parallel to this and my positive y direction to be parallel to this so that the direction of motion is positive, and that the y direction is perpendicular to the direction of motion. So that means that in this case, the sum of the forces in the y direction are equal to 0, force normal minus the force of gravity times the cosine of theta. So we know that the normal force is equal to mg cosine theta. And I'm going to go ahead and stop there. I'm going to move on to the forces in the x direction, which I know are also equal to 0 because constant velocity. In this case, we're going to have F minus the force of kinetic friction minus the force of gravity times sine theta. So we know that F is equal to mu times the normal force plus mg sine theta. And we can further simplify that to the coefficient of kinetic friction times what we solved to be our normal force earlier, mg cosine theta plus mg sine theta. And since we're solving for the power from the motorized gear, one of the ways that you can compute power is by multiplying the parallel force to the velocity. So in this case, the force we're solving for is the force from the winch, which is moving in this direction, and that also happens to be the direction the velocity is moving, meaning those forces are parallel, and we can multiply those two numbers in order to find the power supplied by the winch. So we're going to end up plugging in numbers to find F and multiplying that by the velocity. So what I do from here on out is pretty much just plug and chug, but I'll go ahead and go through it. So F equals 0.18 times 31.8, 9.81 cosine of 20, and I'm going to go ahead and move down a line just so it's not super cramped, and then plus 31.8 times 9.81 times the sine of 20, and that means F is roughly equal to 159.462 newtons. And then in order to find the power from the winch, we're going to go ahead and multiply that parallel force by the velocity. In this case, that means power is approximately equal to 159.462 times the value we were given for the velocity, 1.76. So power is approximately equal to 281 watts, and that's rounded for sig figs.